Hi guys, this is going to be our Unit 3 final exam review. Let's just jump right in. It says if cosine of theta equals -2/5 and theta is not in quadrant 3, evaluate tangent of theta. Well, the first thing I want to do is draw a picture, and I need to identify what quadrant I'm in. So you'll notice that we have that cosine is negative, which means I can be in either quadrant 2 or quadrant 3. If I do, all students take calculus. Cosine's positive in 1 and 4, so it's negative in 2 and 3. But it says that theta is not in quadrant 3, so that means I have to be in quadrant 2. So I'm going to just start by drawing my picture. We always draw out diagonally and then drop to the x-axis. So here's my theta. Remember, cosine is a over h. It's adjacent over hypotenuse. So it's going to be backwards to a hypotenuse of 5. Okay. We need to evaluate tangent. Tangent is O over A. So just in case you guys have forgotten, we're using SOHCAHTOA for all this. To help us out. Okay. Which means if I need O and A, I'm going to need this side over here, and I'm going to solve for that side using the Pythagorean theorem. When we use the Pythagorean theorem, we're using the length. So I know this is backwards too, and that's going to be important for the sign of our answer. But when I'm doing the Pythagorean theorem, I'm just going to use it as 2. Remember, when I do the Pythagorean theorem, the hypotenuse has to be on the side by itself. So I'm going to subtract 4 on both sides. And then I'm going to take the square root. Now, I know when we do things in algebra, but in this case, we specifically want the length. We also want to look at which direction it's going. So since this is going up, this is going to be a positive root 21. So now on for my answer. Remember, tangent, that's what we want, is O over A. The opposite side is root 21. The adjacent side is -2. Okay? So let's think about this answer real fast, because you'll notice our answer should be negative, or we have it as being negative. Let's see if that makes sense. We're in the second quadrant. In the second quadrant, tangent is negative. That's good. Okay, number 2. It says if the coordinates of point P are -2, 3, and P lies on the terminal side of an angle, or of angle theta, then cotangent is what? So P is backwards 2, up 3. Here's P, and it says that P lies on the terminal side of the angle. Well, we can turn this into a triangle. We went backwards 2, and we went up 3. So that's what we know so far. We want cotangent of theta. Cotangent's the reciprocal of tangent, so tangent is O over A. That means cotangent is A over O. Well, wait a minute. We already have the adjacent side and O, so I don't actually have to use the Pythagorean theorem to solve. So cotangent of theta is going to be the adjacent side over the opposite side. Let's think about this sign. Tangent and cotangent are negative in the second quadrant, so our answer makes sense that it's negative. Okay, number 3. If sine of theta equals -3/4 and it is not in quadrant 3, evaluate cosine. Well, we know that sine is negative, which could lead us to being in quadrant 3 or quadrant 4, because sine is positive in the first 2. It says we're not in quadrant 3, so that means I have to be in quadrant 4. So let's draw our picture. Sine is the opposite side over the hypotenuse. So the opposite side, so here's my theta, is 3. My hypotenuse is 4. We need to think about that negative. The hypotenuse is always positive, and it makes sense that the 3 is negative because it's what's going down. We want to evaluate cosine. Well, cosine is A over H. Let's see if we have that. We have H. We don't have A. So to solve for this side, we're going to use the Pythagorean theorem. Remember, when I use the Pythagorean theorem, I'm going to use positive values because we're doing lengths. We don't know this side. The hypotenuse always has to go on the side by itself. I'm sorry, I kind of skipped a step there. Hypotenuse squared. So that's going to be 9 plus x squared equals 16. I'm going to subtract 9 on both sides. So x is plus or minus root 7. We need to think about which one it is. Well, notice I'm going in the right direction, so it's going to be a positive root 7. So if I want cosine of theta, I'm going to take the adjacent side over the hypotenuse. Okay, number 4. It says a tangent of theta equals this, and theta is between pi and 3 pi over 2. Well, let's think about this real fast. Here's pi, here's 0, here's pi over 2, here's 3 pi over 2. If it's between pi and 3 pi over 2, it means I have to be here in quadrant 3. So let's draw our picture. Remember, I always draw my angle on a diagonal, and then I take it to the x-axis. My angle's always close to the origin. Here's my right angle. Tangent is O over A. So my opposite side is 7. This is going to be 5. Now let's think about this. I'm going backwards and down. So these are actually both going to be negative. Tangent was positive because a negative divided by a negative is a positive. But if we want to think about them directionally, this is backwards 5 and down 7. If we want to evaluate cosine of theta, I need a we have the adjacent side, we don't have h, so I'm going to solve for h. Since we're solving for h, that goes on the side by itself. It's going to be 25 plus 49 equals x squared. Oh dear. That's going to be 74. So if I take the square root, I'm going to get the square root of 74. Hypotenuses are always positive. So cosine of theta is going to be A over H. I'm not even going to have you guys rationalize this right now. I'm not worried about that right now. Let's think about our answer. We said our answer is negative. Cosine is negative in the third quadrant, so that's correct. You should always be checking for your sign at the end of the problem to make sure you didn't make a mistake. It's always an easy fix. Okay, number 5. It says given cosine of theta equals 1/3 and lies in quadrant 1, find sine and tangent. Ooh, fun. We know it's in quadrant 1. You always draw it diagonally, drop to the x-axis. Remember, cosine is A over H, so the adjacent side over the hypotenuse. We're definitely going to need this side to solve for both of these. So let's going to do that. I'm going to do this side plus the other leg equals the hypotenuse squared. We can technically simplify the square root of 8. It's 2 root 2, but for right now, I'm going to let you guys just leave it just like this. We're going up, so it's going to be a positive root 8. So if I want sine of theta, that's O over H. And if I want tangent, that's O over A. Now you can leave that just as root 8. But that's fine. Okay, number 6. If theta is in quadrant 4, that was nice that they told us. And tangent is negative 3. Well, I want to turn that into a fraction because this is going to be my opposite side. This is going to be my adjacent side. So think about what's happening. I'm going to the right, so that's positive. I'm going down, so that's the negative one. We need to solve for this. So I'm going to have, remember my sides for the Pythagorean theorem, we're just going to make these positive because of the lengths. We don't care about the direction for the Pythagorean theorem. We're solving for the hypotenuse. Hypotenuse is always going to be positive. And they're asking us to solve for cosine. Cosine is going to be A over H. And again, for right now, I don't need you to rationalize your denominator. I care more about you getting to the correct numerical value than simplifying it. Okay, on to the back. We've done a lot of these, so I'm actually going to skip number 7. Let's just move on to number 8. We're going to simplify. So we're at a point now where we're going to need to use our trig identities. So you guys are going to get, let me find this real fast. On your test, you guys are going to get specifically these formulas. So this isn't perfect. Like for instance, like we haven't rewritten this. Like sometimes in class we rewrite sine squared as 1 minus cosine squared by subtracting it over, or we isolate cosine squared. So all the, like the iterations aren't on here, but this is going to be really helpful for you guys. So if we look on our sheet, notice this is a 1 plus tangent. Oopsies, it's all the way up here. A 1 plus tangent squared. That reminds me of Pythagorean identities because of this squared. So I'm going to go on here and look, and I notice that I do see 1 plus tan squared, and it has a value of secant squared. So the first thing I'm always going to try to do is look for my Pythagorean identities. Now I'm going to look at this. I still think that that looks like a Pythagorean identity. Remember, we have this. Squeeze that in. Let's see if I can rewrite that for this. I'm just going to move that cosine squared over. And you'll notice when I do that, I know that 1 minus cosine squared is equal to sine squared. Okay, dealt with my Pythagorean identities. I don't see much else that I can do. So the last thing I always want to try if I'm stuck, or if either if I'm stuck or I just want to even try this earlier, I'm going to change everything into sine and cosine. You always want to do that before you finish a problem. Secant squared is 1 over cosine squared x times sine squared x. Well, if I combine those, I'm here. Now remember, you don't actually have to write this, but this is the same thing as sine x over cosine x cosine x. Well, that's going to be tangent, that's going to be tangent, so this is going to be tangent squared x. You can do that straight from here if you recognize it, but that's why it is tangent squared. Remember, sine divided by cosine is tangent. Since I have 2 sets of them, it's going to be tangent squared. Okay. Simplifying. When you're simplifying, you're not trying to get to equal anything, you're just trying to get it as simple as you can. Ideally, you'll get down to 1 trig term, but that won't always happen. Number 9, we're going to verify. On the notes page we did in class, I gave you guys some methods to try. One of the big ones is always like try to factor things out first if you can. So you'll notice that I have a cosine squared here and here. When we verify, remember we can't change one of the sides. This is the simple side. We're going to leave it just the way it is. So the first thing I'm going to do is I'm going to factor, oopsies, I need that x. I'm going to factor out that cosine squared, and I'm left then with a tangent squared x. Plus, if I take a cosine squared out here, I still have a 1 left over. Well, we just actually saw this. When I see those squares, I should be thinking Pythagorean identities. So I'm going to immediately change this. We just learned that this has a value of secant squared. We should be writing this each time. Well, we said in the last problem we just did, and one of the last things we want to do, or if we're stuck, is we want to rewrite everything in terms of sine and cosine. Well, wait a minute. You'll notice this goes in the numerator, this goes in the denominator. These are going to cancel out. So we're left here. Remember, you always have to finish with a final statement showing that this side is equal to this side. We need it to be 1, so my final statement should be 1 equals 1. Okay. Number 10 is a little bit tricky because they're both what I think of as equally complicated. I'm gonna mess with this side, mostly because I notice this side only has sines. This has sines and cosines. So I have a feeling that there's more I can do over here. You guys will also notice that if you look on your formula sheet, that these 2 things that we have, hold up, 1 minus 2 sine squared, are actually on your double angle formula sheet. If we're going to prove something through verifying, we can't just state that this is this. We need to give another reason why, and we actually can using the Pythagorean identities. Remember, we need to get this down to only sines, and I know that cosine squared is part of the Pythagorean identity. Sine squared plus cosine squared equals 1. And I can get this by itself if I move that sine squared over to the other side. So I'm going to rewrite this cosine as 1 minus sine squared x. That's what I can rewrite cosine squared as, and then I still have this left over. Okay. I will let you not write this side each time if it's the one you're not changing, but you do need to put it back at the end. Okay, so really what I have is 1 minus sine squared x. There was nothing to distribute the front. Minus sine squared x. Ooh, sorry, I've been using x's. I should be using thetas. Okay. Well, wait a minute. I'm subtracting sine squared twice. So that means I'm subtracting 2 sine squared thetas. And you'll notice now it matches. So yes, I'm aware that that formula was directly under there, under double angles, but we should be showing it in a different way, and we can actually use the Pythagorean identities to do that. Okay. Last but not least, we have our double angle problems. You'll notice that we have cosine, we have sine. And we're going to use this. But if I start here, if I look at my formula sheet, I'll notice that cosine of 2 theta is equal to cosine squared x minus sine squared x. And sine of 2 theta is 2 sine theta cosine theta. Sorry guys, I keep doing the thing where I'm changing my variables. I'm sorry. So you can tell, I mean, so this one has some other options, but regardless, I'm eventually going to need this sine theta for over here, and I only have cosine theta. So these are my formulas. I just need to figure out what cosine theta is. So I'm going to start by drawing a picture. We did one poor thing. We didn't give you enough information to know what quadrant this is in. If we don't assume principal values, cosine will either be in the first or the second quadrant. Since it's positive, I know it's going to be in this quadrant. So cosine is adjacent over hypotenuse, and hopefully you'll recognize right away that this has to be a 3. So for this picture, sine of theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse, and that's all I need for these formulas. So I'm going to start plugging in. Remember, this is the same thing as cosine squared minus sine squared. Well, the value of cosine is 4/5. The value of sine is 3/5. That's going to give me 16 over 25 minus 9 over 25, which is 7 over 25. Over here, we need 2 sine theta, that's 3/5, times cosine theta, that's 4/5. If it helps you, remember this is 2 over 1. 2 times 3 is 6. 6 times 4 is 24. Oopsies, I'm trapping things. And 1 times 5 is 25. Okay, so if you see double angle stuff, just make sure that you go through and use the formulas, draw a picture to get any information you need. Here's something else that I could ask you on the test. Well, remember, tangent is just sine over cosine. So I have sine of 2 theta. I have cosine of 2 theta. Sine of 2 theta was 24 over 25. Cosine of 2 theta was 7 over 25. I can do a copy dot flip. So you'll notice my final answer would be 24 over 7. So if I asked you to do tangent of 2 theta, that's something you can still do because you've already found sine and cosine of 2 theta, so you can divide them. You get their quotient to get tangent. Okay, that's unit 3.